dspy's streaming functionality transforms synchronous prediction modules into asynchronous generators, enabling incremental output processing through a wrapper pattern. This mechanism leverages Python's Asyncio framework to yield partial results as they become available, rather than waiting for complete computation. We're about to examine how a simple dspy.Predict module gets wrapped with streaming capability using dspy.Streamify, then invoked within an async context to process and display intermediate outputs. The code demonstrates basic async iteration over a prediction stream, handling both partial results and the final prediction object.
Import Asyncio. Import dspy. dspy. Configure elm equals dspy. lm OpenEye/GPT-4o mini. Hash create the program and wrap it with streaming functionality. Program equals dspy streamify predict QA. Hash use the program with streaming output. Async def use streaming. Output equals programmed equals why did a chicken cross the kitchen? Return value equals none. Async for value and output. If isinstance of value dspy.Prediction. Return value equals value. Else. Print value. Return value. Output equals Asyncio. Run streaming. Print output.
This code demonstrates how to implement streaming functionality in dspy using the streamify wrapper. The pattern wraps a basic dspy.Predict module to enable incremental output processing, which is particularly useful for handling large language model responses that generate text progressively. By converting the synchronous prediction into an asynchronous generator, the code allows for real-time processing of partial results as they become available from the language model. The implementation uses Python's Asyncio framework to handle the asynchronous stream, where each chunk of output is yielded as it arrives. The useStreaming function iterates through these chunks, distinguishing between status messages which are printed immediately and the final dspy.Prediction object which is returned at the end. This approach provides better user experience by showing progress in real time while maintaining access to the complete prediction once processing finishes. The trade-off here is between simplicity and control. While the basic streamify wrapper handles most common cases automatically, more complex scenarios might require custom status message providers or stream listeners to fine-tune the streaming behavior. The example shows the default configuration where all output chunks are processed sequentially, but the framework supports more granular control through additional parameters like stream listeners for targeting specific output fields. Let's break it down.
Import Asyncio.
Imports Python's built-in Asyncio module for writing asynchronous code using coroutines, tasks, and event loops.
Import dspy.
Imports the dspy framework, providing access to its core functionality for building and composing language model programs.
dspy. Configure elm equals dspy. lm OpenEye/GPT-4o mini.
Configures dspy to use OpenAI's GPT-4o mini model as the default language model for all subsequent operations. The dspy configure function sets the global LM provider, and dspy LM OpenEye/GPT-4o mini specifies the exact model to be used. This line ensures that any dspy module or prediction that follows will utilize this particular language model unless explicitly overridden in a specific context.
Hash create the program and wrap it with streaming functionality. Program equals dspy.Streamify.Predict QA.
Creates a dspy program using the predict module with a signature that takes a question input, Q, and produces an answer output, The streamify wrapper modifies this program to stream its outputs incrementally rather than returning them all at once, while also providing progress status messages during execution. The resulting program variable holds this streaming-enabled prediction module ready for use.
Async use streaming.
Defines an asynchronous function named useStreaming with no parameters. The function is declared but not implemented in this segment, indicating it will contain streaming-related logic when completed.
Output equals programmed equals why did a chicken cross the kitchen?
Calls the program function with a question parameter asking, why did a chicken cross the kitchen? And assigns the returned result to the variable output. The line demonstrates invoking a dspy program with a specific input query and capturing its response.
Return value equals none.
Initializes a variable named return value and assigns it the value none, indicating no return value is currently set. This is a common pattern to establish a default return state before potential conditional logic that might modify it later.
Async for value and output.
Iterates asynchronously over each value in the output sequence, processing one value at a time as they become available. The async for syntax indicates this is an asynchronous iteration, meaning the loop will yield control back to the event loop between iterations if the output is an async iterable like a stream or a sync generator. Each iteration assigns the next available value to the variable value for use within the loop body.
If instance a value, dspy.Prediction.
Checks if the variable value is an instance of the dspy.Prediction class, which represents a prediction object containing the output of a dspy module. This type check ensures that subsequent code handles value appropriately based on its type.
Return value equals value.
Assigns the value of the variable value to a new variable named return value. This creates a reference where both variables now point to the same object in memory, allowing the value to be accessed through either identifier.
Print value.
Outputs the value of the variable value to the standard output stream, displaying it in the console or terminal where the program is running. This is a basic debugging or logging operation that makes the current content of value visible during execution.
Return value.
Returns the value stored in the variable return value to the caller. This is a standard return statement that exits the current function and passes back the specified value.
Output equals Asyncio. Run streaming.
Runs the useStreaming coroutine synchronously using Asyncio, run, which executes the async function and returns its result. The output of this execution is assigned to the variable output.
Print output.
Prints the value of the variable output to the standard output stream. This displays the contents of output in the console, which could be a string, object representation, or any other printable value depending on what output contains. Wrapping a dspy.Predict module with streamify transforms synchronous prediction into an async generator, enabling incremental output processing. The async for loop iterates over partial results as they arrive, distinguishing between status messages printed immediately and the final dspy.Prediction object returned at completion. This pattern leverages Python's Asyncio to provide real-time feedback while maintaining access to the complete prediction. The trade-off is simplicity versus control. While the default wrapper handles most cases, complex scenarios might require custom stream listeners for granular output handling. The key insight is that streaming doesn't just improve user experience. It preserves the full prediction object for downstream processing, bridging real-time interaction with structured results.
The printer spits tokens like a chicken pecking grain. Yet the answer nests whole before the question hatches.